Hello everyone. So in the last class, we have discussed the classification of elements in the periodic table, and today we are going to discuss the periodic properties of the elements. So here we are going to discuss about the following periodic properties. The first one is atomic radius, and the second one is electronegativity. Third one is ionization potential. And the fourth one is electron affinity. And this ionization potential can be called as ionization energy also. So we can call it as ionization potential or ionization energy, and we call it as, in shortcut we can write IP, and for this electron affinity we can write EA, and this electronegativity as EN. And before we move to this periodic properties, so you need to remember 2 points. So an atom of an element contains a nucleus where protons and neutrons are placed, and around this electrons will be revolving around this nucleus in these electron shells. That means in the nucleus, the protons which represent positive charge, they are present in the nucleus, means the nucleus will be positively charged, and as the number of protons increases, the positive charge in the nucleus also increases. So remember this point, the number of protons in the nucleus increases, then the charge of the nucleus also increases. Similarly, the electrons are revolving around this nucleus in circular orbits. They are called shells, and as the number of electrons increases, then what happens? The negative charge in the electron shells also increases. And so when there is an increase in the charge, okay, so when there is an increase in the positive charge and the negative charge, then the attraction between the positive and the negative charge will be increasing. Okay, that means higher the charge, greater will be the attraction force. So you can write this attraction force is directly proportional to the charge. Okay, so as the charge increases, okay, so then what happens? The attraction force between those charges also increases. Okay, let's see what is this atomic radius. So this atomic radius can be defined as the distance between the center of the nucleus and the outermost shell. In case if this is the outermost shell of the atom, the distance between the center of the nucleus and the outermost shell is called atomic radius. Okay, and let's see how does it change down a group and across a period in the periodic table. Right, so if you take the periodic table, so down the group, let's see the change in the atomic radius down the group. So here we have 7 vertical columns. So here we have 7 horizontal rows, that is 7 periods we have in this periodic table, and this period number indicates the number of shells present in that atom of that element. So if you take the element in the first period, that will have only 1 shell, and if you take the element which belongs to the second period, so it will have 2 shells, and element belongs to third period will have 3 shells. So as you can see here, as the number of shells increases down the group, as the number of shells increases, what is going to happen to the atomic radius? The atomic radius is increasing. Okay, down the group, what happens? Atomic radius will be increasing. So obviously what happens when the atomic radius increases, the atomic size also increases down the group. Let's see what happens across a period in the periodic table. So if you take a particular period, let us say it is period number 3. Period number 3. Since all these elements belong to period number 3, so they all will have only 3 shells. So here the number of shells will not change. So the first element of the third period will have 3 shells. If you take second element, it will also have 3 shells. And if you take fourth element also, it will have only 3 shells. So here across the period, the number of shells is not going to change. But so if you move from left to right, we all know that the elements in the periodic table are arranged in the increasing order of their atomic number. See, when you take period number 3, it starts with sodium, whose atomic number is 11. Then 12, 13, 14, 15, 16, 17 and 18. So here starting with sodium. So when you take sodium atom, so in this you will have 11 protons in the nucleus and 11 electrons in the electron shells. Now, so this 11 protons can be taken as 11 plus and these 11 electrons can be taken as 11 minus. Okay, so now if you take any other element, let's say it is atomic number 16 and it is sulfur. So now sulfur's atomic number is 16, so it will have 16 protons in the nucleus and 16 electrons in the electron shells. That means you will have 16 plus in the nucleus and 16 minus in the electron shells. Now if you compare the attraction force between the nucleus and electrons in these two cases, so in which case you believe that attraction force is stronger? So as I told you already, the attraction force is directly proportional to the charge, the magnitude of the charge. So in which case the atom has higher magnitude of the charge? In case of sulfur, because they have 16 protons and 16 electrons. So comparatively what happens here, the attraction between this 11 protons and these 11 electrons comparatively less when compared to the attraction between 16 protons and 16 electrons. So that's why, since the attraction force between this nucleus and electrons is stronger than the element which is on the left side, what happens? The electron shells will come close to the nucleus. It is because of what? It is because of the stronger attraction force between the protons and the electrons. Nothing but the attraction between the nucleus and the electron shells. So as the charge increases, then what happens? Attraction also increases. That's why the atomic size across a period will be decreasing, because the attraction force between the nucleus and electrons will be increasing across a period. So across a period, atomic size or atomic radius will decrease. It will decrease. And what is the reason? The reason for this is due to the increase in nuclear force on electrons. So the nuclear force or the effect of nucleus on the electrons in the shells will be increasing. So that will attract electrons closer to the nucleus. So that is the reason why the atomic radius decreases when you move across a period. Now you may have a doubt that down the group also the nuclear charge increases, means down the group also the atomic number increases. But down the group what happens, the number of shells will be increasing. So the increase in the number of shells will dominate the effect of nucleus on the electrons. So that's why even though there is an increase in the atomic number, increase in the nuclear charge, so here the atomic size will be increasing down the group and the nuclear effect on the valence electrons will be decreasing. So let's write these points here. So if you understand this, you can understand the remaining periodic properties. So this is about the nuclear effect. Nuclear effect on electrons. So across a period, the nuclear effect, or you can write nuclear pull. So the nucleus will be pulling the electrons because nucleus is positively charged and electrons are negatively charged. So that will be pulling the electrons towards the nucleus. Across a period, the number of shells remains same, but the nuclear charge increases. So the nuclear effect or the nuclear pull increases on the valence electrons. And down a group, the nuclear effect, or you can write nuclear pull, decreases on the valence electrons. So this is the important point you have to remember. So in case of remaining periodic properties also, okay, so across a period the nuclear effect or the nuclear pull will be increasing, whereas down a group nuclear effect will be decreasing. So these two are very important for the next periodic properties also. And let's see what is the second periodic property. The second periodic property is electronegativity. Electronegativity. So what is this electronegativity? So this electronegativity is nothing but the tendency of an element to attract electrons towards itself when it is in combined state. So what is the meaning of this combined state? So let's take an element A and B. Okay, so element A and element B, and these two are forming a molecule by sharing electrons. So that is called a chemical bonding. And so this A and B will be mutually sharing these two electrons, and they are in chemical combination because they form a chemical bond. And now, so each element A and B, so both will have a tendency to attract these electrons to themselves. So A will be pulling the electrons to itself, and B also will be pulling those two electrons towards itself. So that tendency of attracting electrons towards itself when they are in combined state, so that tendency or that nature is called electronegativity. Okay, so you can just simply understand what is electronegativity. It is nothing but pulling of the electrons. Electronegativity is nothing but the element will be the nature of the element to pull the electrons towards itself. Okay, now let's see how does it change across a period and down a group. So let's see across a period. So we already studied that across a period the atomic size will be decreasing. So if this is an element and its size is this much, and the electronegativity of this element means the tendency to attract the electrons which is in the outermost shell. And similarly, you are comparing the electronegativity of these two elements, let us say A and B. So if you take this other element, okay, and its electron is here, and it also will have tendency to attract that electrons. Now, in which case the nucleus will be able to attract the electrons more strongly. So in which case you think? So obviously it will be in this case, because the nucleus is very close to the electron. It is very close to the valence electron. So it can easily pull the electrons. So the electronegativity of this element B will be more than that of the element A. Okay, that means the electronegativity of an element which is on the right side will be greater than the element which is on the left side in the period, and it continues the same way. So if you take this and this, so its atomic size is even more small. Okay, so this is smaller than this, so definitely this will have greater electronegativity compared to B. And if you come to this one, let us say it is element D, and even if you take this element, its atomic size is very, very less. So when you compare the electronegativities between C and D, so definitely D will be having higher electronegativity. That means electronegativity increases across a period in the periodic table. Okay, electronegativity increases across a period in the periodic table because the atomic size decreases. The same way, the nuclear effect or the force of nucleus on the valence electrons also increases because the atomic size is very less. And let's see what happens. Now let's see what happens to the electronegativity down the group. So here we know that down the group, nuclear effect decreases on the valence electrons, or the atomic size increases. Okay, the atomic size will be increasing. So the first element of the group will have only one shell, and the second element will have two shells, and the third element will have three shells. It goes on like this, and at the same time the atomic size also increases. Now if you compare these two elements, let us say A and B. Okay, so between these two, A and B, so which will be attracting the electrons which are in the valence shell more strongly? So obviously this nucleus is close to this electron, so in this case the electronegativity will be more compared to this. And similarly here the atomic size is increasing down the group. So in this case, if you compare, the electronegativity will be less than that of this B. If you say C, the electronegativity of C will be less than this B, because down the group the atomic size will be increasing and the nuclear effect on the valence electron will be decreasing. So nuclear effect on the valence electron will be decreasing. So the attraction of electron, attracting or pulling the electrons, is called electronegativity, but the effect or the nuclear pull on the valence electron is going to decrease down the group. So electronegativity decreases down a group. And let's see the next periodic property. The next periodic property is ionization potential. Ionization potential. So for example, if this is an atom and let us say this is the outermost shell, and in this I have an electron. Now when I want to remove this electron from this atom, from its valence shell, so then I need to give some energy to the atom so that the electron will overcome the attraction force between the nucleus and the electron ejects from the atom. So to overcome the nuclear pull and to come out of this atom, this electron requires energy, a minimum amount of energy, and that minimum amount of energy, the minimum amount of energy required to remove one electron from the valence shell of a gaseous atom is called ionization potential of that element. And let's see what happens to this ionization potential across a period first. So we all know that the atomic size decreases across a period. Okay, let us say this is the nucleus. Okay, and this is the valence shell, and for this it is the valence shell, and for this is the valence shell. Okay, I'm not showing the inner shells because I'm talking about only valence shell. So now, in which case the electron requires less energy to overcome the nuclear pull and come out of the atom. So obviously in this case, because in this case the electron is away from the nucleus and the nuclear pull will be comparatively less when you move across the period. Okay, so if you move to the right side, so here the electron little bit close to the nucleus. So in this case the electron requires more energy because the nuclear pull is increasing as you move to the right side. And if you come to this one, now here the size is even more less. So now the electron is even close to the nucleus and this requires more energy to come out of the atom. That means the ionization potential will be increasing across a period, because across a period the atomic size will be decreasing, at the same time the nuclear pull on the electrons will be increasing. So this is about across the period. Now let's see down the group. So if you move down a group, so what happens? The atomic size will be increasing. The atomic size will be increasing. So now in which case, or what happens to this ionization potential if you compare this atom and this atom? So in which case the atom requires less energy to release the electron? So obviously this one, because the electron is away from the nucleus compared to this. So this requires less energy, that means it requires less ionization potential to remove the electron because the electron is away from the nucleus. So then you will require less amount of energy to release that electron. But in this case the electron is close to the nucleus and it requires large amount of energy to release that electron. So that means as you move down the group, since the atomic size increases, the nuclear pull decreases. The nuclear pull decreases down the group and the energy required to remove the electron will be decreasing. So ionization potential decreases down a group. So this is how ionization potential changes across a period and down a group in the periodic table. So let's see the next periodic property, that is electron affinity. So this electron affinity is just like the reverse of ionization potential. So the next one is electron affinity. So if you see ionization potential, to remove this electron you have to give a certain amount of energy to a particular element. But in case if you want to add an electron, into the valence shell, now it is a reverse process. So in the previous case you want the electron to come out of the atom, but in this case you want to add an electron to the valence shell of an atom, of an element. Then so when the atom takes the electrons, then it will release energy, it will give out energy, and the amount of energy which is released, when a gaseous atom accepts an electron into its valence shell, that energy is called electron affinity of that element. And so this electron affinity or the energy which is released will depend upon the tendency of the atom to take the electron. That means if the element is ready to take electron, then it will give you large amount of energy. If the element is not ready to take the electron, it will release less amount of energy. And let's see what happens across a period. So as you move from left to right, what happens? Same thing, the atomic radius will decrease. Okay, so now in which case you can easily add an electron. In which case you can easily add an electron. So that means to accept the electron, the nucleus must be ready to accept the electron, means the nuclear pull will be higher to accept the electrons. Now when you compare these two atoms, so in which case the nuclear pull will be more between these two. So obviously since it has smaller atomic size, so this will be having higher tendency to take the electrons. Okay, so it can easily take electrons and gives more amount of energy, means it will give you more electron affinity. Whereas compared to this is having larger atomic size. So compared to this is less readily takes the electron and it will give you less energy. That means it will give you less electron affinity. So that means if you move from left to right, the electron affinity will be increasing. So it becomes less to more. So electron affinity will be increasing. It will be increasing across a period. Okay, now let's see what happens down the group. So as you see down the group, the atomic size will be increasing. Okay, so let's take, these are the two elements in the group and the atomic size will be increasing. And let's say this is the nuclei of the atoms. Now, so in which case or which atom is ready to take the electrons? So obviously which has small atomic size that can take the electrons easily, because here the nuclear pull will be stronger. So it can easily take the electrons and it gives more energy, means it will give you more electron affinity compared to this. So it will give you less energy, that is less electron affinity. That means down the group electron affinity will be decreasing. Okay, electron affinity will be decreasing down the group. Okay, so we have one more periodic property, that is metallic character. Metallic character. So this is also called electropositivity. Electropositivity. So it is just opposite to electronegativity. We have already learned what is electronegativity. It is the tendency to attract electrons. Now it is opposite. Electropositivity means the tendency to lose electrons. So that is called metallic character. Okay, and this is exactly opposite to electronegativity. Across a period, electronegativity increases across a period, whereas this metallic character, it is opposite to that, so it will decrease across a period. And down the group electronegativity decreases, whereas this metallic character increases down the group, because the atomic size will be increasing down the group. So as the atomic size increases, the nuclear pull on the valence electrons will be decreasing and the tendency to lose these electrons also increases. Okay, so when you compare these two, so this electron is under the higher influence of nucleus because it is close to the nucleus, whereas this one it is little bit away from the nucleus. So comparatively it will be under a less influence of nucleus. So comparatively this electron can be removed easily. So its tendency to lose electron will be higher compared to the element which is placed above it. Means as you move down the group, the metallic character increases, means the tendency to lose electron increases. Okay, so this is about the periodic properties of the elements. Okay, so in the next class we'll discuss the board questions and the important questions regarding this periodic table.